Hello, Tube Timers. Well, I got a new piece of equipment from an electronic auction the other day, and it's a bridge. I wanted to have a video on it right away, but when I bought it from the auction, it was an online auction. The publication said, the auction publication said that on this particular instrument there was some corrosion in the battery box. It takes 4D cells batteries to operate it. And I thought, well, okay, I won't mess with that just yet. I'll get to cleaning it out a little bit later, but I want to see if this thing even works. When you buy things online, you never know. It's one of my favorite electric auction houses. Anyways, I got out this Heathkit power supply here. It's an IP-27, a really nice low voltage power supply, I must say. But I turned it on and it was acting kind of weird, because I like to turn things on, try them out, plug it in. And allow me to show you. This is the voltage control, and this is the meter that shows what voltage we're putting out. And you can adjust it. It goes down and up in this range between 10 and 15 volts, and that is the first indication of a problem. I'm supposed to be between 10 and 15 volts, as you see right here, and where am I? 6. So I thought, I'll turn it up, see what happens to the 15 to 20 volt range, which would put me between 15 and 20 volts in the red range, which is way the heck down here. The meter, by the way, on something like this is meant just for a guideline. You should use your voltmeter to dial in your voltage exactly, but you need to kind of know where you're at. So I turned it up. Listen. Very faintly, there's a click in there. Hear it? No, it's not my switch making that noise. That's the overcurrent relay grumping at me that it's throwing into overcurrent, and I have no load on it yet. So that's a problem. And I thought, crud. Now I gotta fool with this darn thing. I like to use antique equipment, but one of the problems with antique equipment is it can fail on you at any time for any reason. Well, the reason's age, I guess. And when you want to go ahead and do something, the equipment doesn't work. But that's the price you pay for having equipment I can afford. So let's turn this thing off and unscrew the top. I've already taken the liberty of removing the 4 screws. There's one on the front and on either side. We'll open it up. And what do we see? Well, we see the insides. Let me see if I can get you a view up here. A good view. Now, I've been in this power supply before, so I've marked a few things for my convenience next time. I do have this thing plugged in, so I can't be waving my screwdriver wand around here. I've identified a few transistors, Q2, Q3. There's a fuse down below. I wrote some information here, so the fuse blows. I can replace it with the right one. Q4 and Q5. So I could use my electrical engineering training and troubleshoot the circuit, see what's going on. And that would take a while. So I thought, hey, let's get the manual out, because Heathkit has a lot of very good manuals. And we're going to go to the page in the manual on the troubleshooting chart. So we whipped out the troubleshooting chart. I'll kind of like just show a little bit here with the troubleshooting chart. And I'm taking a look at the symptoms. What are the symptoms I'm seeing? Well, as I go scooting on down here, low output voltage or no response from fine. Well, that's not exactly right. No output voltage, that's not right. High Zener current, no, we don't even check that. Loss of current limiting, not really. It still limits, just not right. Relay pulls in on any load over 6 volts. Well, the relay's pulling in. And when I first turned it on, the relay chattered. So if you look at the possible causes, we have transistor Q2, Q4 or 5, or Q2 on these two. So the common thing here is Q2. So that's the very first thing we're going to take a look at, is transformer, or is transistor Q2. Look at that. I've already got a place to go, and I haven't spent 2 minutes on it yet. Now, what we're going to do is take a look at transformer Q2. Now, this is a bit of a circuit, so I apologize for the show here. But let me point this out, and hopefully you can see it well enough. This is Q2. It's called the error detector. And what that does is it tries to change your voltage with what you set it to be, and it tries to keep your voltage well within what your set point is. So for that to be messing up your voltage makes an awful lot of sense. Q4 and Q5, they're what they call pass transistors, and pass transistors are the devices that actually regulate your voltage on the way out. So I would guess the first thing we're going to do is take a good look at Q2. We'll have to test it, see if it's good. Alright, so back to the equipment. As you can see, this is Q2. And I turned it off, or into standby at any rate. And this is a very interesting looking transistor. What in the world is this? So when I first opened it up, several years ago when I first got it, I had to fix it before it would work. That's when I label all these things. I was looking at it, and I pulled it up, and I go, well, what the heck is this? The thing is in a socket, a transistor socket, and it's got this great big lug crimped around it. And you can see back in the day, I like to make things easier for me, so I know it's a 2N55-3. Here's the emitter, the base, and the collector. So I like to put this stuff on there so when I'm making my measurements, I can sort of tell. The 2N2553 is, wait for it, a germanium transistor. Oh no, those things are scarce as hen's teeth. And this must have been a special one. Germanium transistors are 1950s and 60s technology. Today we use, for the most part, silicon transistors made from silicon. The germaniums are made from germanium, of course. How obvious is that? And they've fallen out of favor for the last 30 years or 40 years because they're a bit delicate. I mean, they don't have much of a power range compared to silicon. They're easier to damage, and they're pretty ornery overall. However, they're making a bit of a resurgence because the guitar amplifiers like to connect their guitars right to the base of this germanium transistor because it's got a very low junction voltage. Okay, enough of that yammering on. So when I looked up this 2553 on the internet, and I can find one like this, $70, new old stock, maybe $100 new old stock. That's where it kind of ran around. Well, I didn't even pay $100 for this power supply, so I'm not going to pay it for not one, but two of the same transistors. This is the same transistor. I hope it's not bad. Now, I could convert this to silicon, but you got to be careful. Silicon has a junction voltage of 0.7 volts, while germanium has a junction voltage of around 0.2, and that would change all the bias levels on the transistors. Sometimes it makes a difference. Radios and amplifiers, definitely. But on a power supply, maybe yes, maybe no. So I said, okay, I'm going to get a hold of my most favorite transistor, the 2N2222. That works for everything. So I looked up the 2N22, or looked up this 22N2553, and it turns out that this transistor is a PNP transistor. My 2N2222 is an NPN. Won't work. So I have to find my favorite transistor in its complementary form. If the 2N2222 is a NPN transistor, the complement to that is the 2N2907, which I guess makes it, by extension, my other favorite transistor, because it's the complement of the 2N2222, and it is a PNP transistor. So I went to my stock drawer, and lo and behold, I found my 2907. So I thought, okay, before we stick anything anywhere, let's test it to see if this transistor is really bad. So I'm going to try to avoid giving you too much grief for this thing, but I have this favorite device of mine called a Sencor TF151A. It's a handy little transistor tester. It tests transistors and field effect transistors, and it's pretty. How can I say it tells. If it's bad, this thing will tell you it's probably bad. Okay, so let's see if this particular transistor is good. Now, this tester has 3 leads that comes out of it right now, and that's the emitter base and collector of the transistor to connect to the transistor. So, thank goodness I labeled these things because I can pick this up and look at this and say, oh, all right. So, here's my emitter lead. Black is emitter, and that's because it's labeled on the machine that way. Black is the emitter. Yellow is the base, which is the middle connection. And red is the collector. All right, so what's happened here? We have set up our transistor for regular transistors, low power. I think that's right. Well, let's take a look in the instruction manual. The instruction manual gives us some indications, and the 2N2553, it's a high power device. So we're going to click this over on high power. It is a PNP germanium, and the minimum gain should be 20, or whatever signal comes in is going to be amplified by 20. The maximum is 60, so they're going to give us a range of 20 to 60. So, okay, I've got our transistor wired up, and now we're going to measure the gain. Now what you do is you connect it, and then you adjust it so that the needle goes to the beta calibration. Beta is the gain for transistors. And then we push the gain button to measure it. Now remember, this has to be between 20 and 60. Oh, gain's a little bit higher than it ought to be. Don't know why. But it's definitely between 20. It's past 20 and 60, which is an indication of a problem. Another thing that happens is that the transistor will become leaky between the collector and the base, and this device will tell us if it's leaky. And sure enough, ooh, what's going on here? This isn't right. Ooh, this thing is really, this should be, this is microamps, okay? So 0 microamps is where you want to be. You don't want leakage. And this is over 5,000 microamps, which is past 5 milliamps. This thing is toasting. It's pooched. The emitter to or the collector to base junction is shot. What a shame. Okay, so we know this transistor is bad. How about this transistor? Might as well test this one as long as we don't know. Maybe it is bad. So we'll connect again the collector to the collector. It's so nice to write things neatly write things on components and placement in the device so that you can actually reference it while you're troubleshooting and not going back and forth between a data sheet. Okay, so we're going to hook this up in the leakage mode. Oh, look how low the leakage is. It's 20 microamps. So you can already see the other one pegged the meter. This one is down here in 20 microamps. And by the way, the maximum leakage, according to the setup book, is 50 microamps. So this fellow is doing quite well for us right now in the leakage department. And we're going to go to our gain adjustment. We're going to go to our gain and hopefully get something between 20 and 50 or 60. And we are right on the top end. Excellent. So this one's putting back. So I'm going to put this transistor back in its slot. In its socket, because it's not bad. What am I going to do with this poor fella? She's sad and tired. So I did get my favorite silicon transistor out, my 2907 complement, the 2N2222. And you know what I'm going to do? I'm just going to stick it right in there. I mean, what the heck? What's it going to do? Poof? Maybe make a little bit of a spark? I don't know. So let's put this in the spot. Okay. This is a high power, relatively high power device. This is a low power device. That's the only funny thing about these two. So this might get over in such a big hurry. It's surprising. Okay. So let's turn it back on and see what we have. Zoop, back down to the machinery here. Down to the business end. And we're going to turn everything down to low where it's supposed to be. We're going to turn it on. And we're going to begin to, I got to turn it on first. This reset standby, by the way, resets the overcurrent relay because it latches on. So if it goes to overcurrent, you got to reset it before you go back to DC. So, this looks good. 0.5 to 5. All right, that's on the red scale. So that's 5 volts. 0.5 is down there a little bit. Look at that, I can crank it right up to 5 volts. Here's 5 to 10 volts. Now notice it's in ranges, so it's not like you get 10 volts. You're going to get something between 5 and 10. And at the low end, you should be just below 5, as we are. And at the high end, just above 10. And we are. So far, so good. Boy, we got lucky here, maybe. And then there's 10 to 15 volts. I'm going to crank this up all the way. 15 volts. 20 goes to the red scale. It's on 20. 25 stays on the red scale, and it's pretty close to 25. There we go. 25 to 30 should take us to 30. 30 to 35 should take us to 35. It shows 34. Let me explain about that in a minute. 35 to 40. 45 or 40 to 45, and then 45 to 50. Brilliant. So all the voltage range works. I do not expect it to be exactly correct for dialing voltages and ranges because I'm going to have to go through a calibration procedure. And that'll take a little bit of time. So what we're going to do is turn it back to 10 to 15 volts. And what I have here is connections to my load. I've got a 16 ohm load, and I'm going to plug it in here, and we're going to see if this thing operates under load. So it's 16 ohms, which means if I have 8 volts, I should be putting a half an amp into this thing. All right, we're at about 8 volts. Now there's a switch down here that allows me to switch between voltage display and current display. When I flick this down, it should go to the black 5 to 10, or a half amp should go to the 5. Does, just about right on the money. Perfect. So this thing right now is pushing out 1 ampere. If I raise it to 16 volts, then you would expect the voltage or the current to go to 1 amp. 10 to 15, 15 to 20, and that is 16 volts is right there. That's the red scales. You have to mind your red scale, black scale, all that nonsense. So 16 volts on the 10 to 20 is right where you show. 3 divisions past the 10. I'm going to flick it on the current range, and we should go to 1 ampere. Bang, right on, 1 amp. 15 to 20 range, 1 ampere exactly. So, what does this tell us? I think we fixed our power supply, more or less. I'm going to have to find a transistor that will meet the characteristics of the 2553 by going through and comparing modern silicon transistors to the ratings of the old germanium transistor. I know the one I put in is not powerful enough to probably run it trouble-free. So the next step will be to order the proper transistor, or what I think is the proper transistor, put it in, go through the calibration procedure, and make sure everything's up to snuff. But at this point, I have no reason to think it won't, and so this is where I'll let you all go on your merry way this day, because we are done. Tube timers, thank you very much for watching. Please consider subscribing and hitting the thumbs up button so I understand what kind of documents you like. This will be a ToobTime Sidetrack, so it should be kind of interesting, just a shorty. And as soon as I get the proper transistor in and calibrated, well, then we're going to go take a look at that Wheatstone bridge that I bought at auction. All right, Tube timers, take care, and we'll see you at the next video.